theory, peer-to-peer network can be an alternative to transactions completed through our current centralized single-server system. It is built on group consensus, thus equalizing the bargaining power of the parties involved in the transaction. The peer-to-peer network system also automates the transaction through the blockchain, which validates the transactions based on the prerequisites already submitted by the members of the peer-to-peer system. Many articles have revealed how currently the finance system, government, and the digital or the creative industry has adopted the peer-to-peer network to help make transactions more secure, egalitarian, and efficient. Furthermore, the peer-to-peer network has been shown to also improve supply chain management. Yet, typically when people are talking about decentralized peer-to-peer network, they tend to get lost in highly technical terms, which sound alien to the lay people. Therefore, it will be interesting to dissect how the peer-to-peer system works, right from its definition, its differences from the centralized system, and its current applications in people's everyday life, as well as its security concerns. I'm your host, Sebastian Partogi, and I will explore the issue with Blockchain CEO Roberto Capodieci. So, good morning, Roberto.
Good morning.
So, my first question will be what is the peer-to-peer network?
So peer-to-peer network is a network made by many computers, which are referred as nodes, that talk to each other, but each node talks to a limited set of other nodes. There is no understanding of the full dimension of the network by each node. So they use what can be similar to gossip. So when an information passes to another node, is then bounced from that to others until the information reaches the full network. Is sometimes used to find paths between one node to another if those are used for communication or streaming of content. So there are many applications of peer-to-peer network that are deployed today. The first old famous one being Torrent as a system to find pieces of files and download them from different nodes. So the peer-to-peer network is necessary to map the position of these pieces of file, and then the party wants to download through the peer-to-peer network localize where are these pieces and connect directly with those computers to download the file, the parts, the piece of the file. Other peer-to-peer network I use for video communication. So for example, I want to call somebody that is in a peer-to-peer network. The peer-to-peer network create a mapping of all the participants so that I can locate the one I want to communicate with and open a connection directly from my computer to the other computer. Other application of peer-to-peer network, the one that is widely used today is for blockchain. And blockchain adopt peer-to-peer network as a system to have an infrastructure where the data are kept and updated, and the information to update this data is distributed to the peer-to-peer network. Usually there are protocols that makes the peer-to-peer network connect one node with the others, and there are rules that automatically blacklist a node given certain behavior, as there is no central authority part that take decision for the whole network. Each node need to make a decision that is potentially similar to the other nodes, but is an individual decision. So if a node decides to blacklist another node because he considers it not reliable, he follows some rules that theoretically are identical to all the other node rules, and if the other nodes find themselves in a similar situation to judge the behavior of a particular node, the same particular node, in theory should come to the same conclusion, which would be blacklisted or not. So that the peer-to-peer network acts as a huge brain that in front of a particular decision, takes in unanimity the same action, because the rule written in each node should be the same. In fact, peer-to-peer network breaks easily when there is an update in the software of each node, and some node react in a way to the software, other node react in another way, and this create what is a little bit of a scission between two subgroups of the full peer-to-peer network, because the behavior changes. Sometimes not all the nodes run in the same operating system, not all the nodes run with the same software, so if an update deploy a functionality which with an operating system react in a way, with another react in a different way, in front of a situation, those that have a set operating system start reacting in a way, and this creates a split between the full network, which happen quite often. That's why it's not easy to implement applications that are for peer-to-peer network decentralized, because it requires a lot of testing before deploying live, because it's very risky to do that.
Yeah, so to help people understand, like, how does it differ from the centralized system? Because I think people are more familiar with the centralized system.
Yeah, to be honest, the majority of people don't even know what is happening behind the application they use in their phone, or when they open a website in their computer. But centralized systems are a unique server computer. They can expand to a full data center, but a unique point of arrival where decisions are taken and responses are given. So if I open a website, most of the time I am talking with a specific server which provide me whatever response, whatever pages I'm looking at the website. This can be a single computer if it's a small website, can be a bigger data center if it's something like a bank or a large, because it's split the operation, but the entry door is one, let's say. Can be a huge or even a distributed data center if it's something like YouTube, Facebook. For example, YouTube, for organizational reason, streams the video from the closest location to the user. So to have a better quality, they have data center in many different countries already connected with the major ISPs. So when you request a video, there is a copy, or the video is just streamed super high speed to the data center and that goes to the user. This is more a federated network that unique organization has to distribute data. So those are the centralized system. Centralized, not decentralized. These are the centralized system, and they work mainly in control of a single person, because even if it's more than one computer is a data center, there is a single company managing all those computers. So it's easy to deploy updates, it's easy to fix problems if they happen, because it's a single person. While a peer-to-peer network, each node is in the hand of a different person. Most of the time peer-to-peer networks are open, so anybody can go in a website or somewhere, download a piece of software from a centralized website, or somebody give to them who is in a magazine, a CD-ROM, whatever it is, and then when they run in their computer, you connect to the peer-to-peer network and become one extra node. So if a peer-to-peer network has 10,000 nodes, there are potentially 10,000 different people managing 10,000 different computers that are connected to this network, which means that if there is to update the software, it's hard to make sure that 10,000 people know that there is an update to make, that 10,000 people are aware where to download it, are willing to do it, so even if the developer is one, it doesn't have a direct control on what is happening, and it just takes a majority of these people to decide to go in their own direction, that they're free to do so, because one of the characteristics of most peer-to-peer software is to be open source. So people can look at the code to know what they're running in their computer correctly, and to know if they can trust the behavior of their software, right? Yeah. So while they don't open source YouTube, they don't open source Facebook, it's centralized, it's closed. What is happening behind the entry door when I connect, nobody knows. When in a peer-to-peer, everybody knows, because obviously they have software running their computer which they have direct control of.
Okay. So, like, what are the benefits or the advantages of the peer-to-peer network compared to the centralized system?
Well, the peer-to-peer network is just a network infrastructure, right? So directly is just not so more advantageous. Actually, is worse than a classic centralized mechanics, because centralized systems are easier to manage, update, are faster. They have a single point of truth, meaning that, for example, in a case where a request from user need to be ordered, a centralized system knows exactly the order they received. But it's the opinion of who's managing the computer to know, right?
Oh, yeah.
In a decentralized system, because there is this gossip of information that goes in waves, if something starts being broadcast from a side of the network, something starts being broadcast from the other side of the network, there is no first or second. Each node has its own truth. There is, when they receive a request from a user, there can be user A I receive first, user B I receive second, because I'm in a certain place of the propagation. In another place of propagation, I receive first user B and second user A. So there is now a way to know in absolute truth who sent things in what order, for example, because is individual of each node, and there is now an absolute truth for the whole network. So this is a disadvantage on one side, right? On the other hand, it's very hard to compromise, or if it's impossible to compromise a peer-to-peer network, right? So there is no central point of failure, right? Okay. So the only way to compromise a peer-to-peer network is to social engineer, so to convince the developer to put the bad code inside and then trigger this bad code. And it happened. It happened with Bitcoin, for example, that they pushed a big proposal that the community realized it was a bad thing. Some people speculated that there are secret services behind that were trying to compromise the system, and very few updated with that update. The majority didn't, and in fact it crashed. As soon as it started, it stopped working.
Oh, okay.
Other times this happens just because the developer don't do a good test quality, and it happened with Ethereum a few days ago. They made this update for one of the version of Ethereum, because Ethereum is developed for many different systems. They introduced a new functionality, and a huge chunk of nodes of Ethereum that had a faulty software update stopped working. And this means that the website like Etherscan was not updated because they relies on this. Obviously, it took them a few hours, if not just 1 day or two, to fix the software. Everybody updated and all went back to work. But the other half was still working. That's the beautiful thing. If the update, we saw that time ago, a few months ago, suddenly Google, many other big things went offline for several hours. And it comes out that some network tools, some network devices that were used by a lot of government and things had some spyware inside for a long time. So they had to replace things and they end up putting everything offline because in a centralized aspect, when there is a problem, it involves everything. Like, so Ethereum half was still alive and updated, and the other half catched up soon after it got fixed. So, you know, it's much more resilient, it's much more strong, stable, and survive bad things when a peer-to-peer network is coded properly, is implemented properly. So because each peer-to-peer has different software, so I cannot in absolute terms say all the peer-to-peer are good, all the peer-to-peer are bad, but the mechanics and the architecture of a peer-to-peer network has this advantage that it cannot be killed, it cannot go down full if there are troubles, which is there is still some part that will survive and then can regrow back to full dimension, which is good.
As long as the developers can fix the problems.
Yeah, correct. I give you an example.
Yeah.
During the past wars, one of the things that was done to conquer a city was to go bomb the electric power. Because the electric power was centralized, so once you bomb that, the full city has no electricity, right? I think in Germany they did something such as making each house use the engine of the Volkswagen Beetle, I think, or Volkswagen Rabbit, power with propane gas LPG, to produce electricity and put it in the network. At this point, they decentralized the production of electricity, which will make impossible for an enemy to remove the electricity from the city, because they would have needed to bomb each house that was producing electricity, which would make the operation impossible. So, centralize single power plant, you bomb it, the full city has no electricity. Decentralizing electricity production in all the city, even if you kill one or two houses that produce, there still be electricity in the network provided by all the other houses. And this is a very good, not even an analogy, it's an actual way of decentralize something, and making a sort of a peer-to-peer network of power generators that put electricity in the grid, making the electricity for the city constantly present. So even if one has a damage or one get taken down, it doesn't matter.
Okay. And before we're talking about supply chain, I would like to ask you, like, what are some of the applications of the peer-to-peer network, like Torrent, for example? Yeah, and then like how users, so like basically like the consensus is created by the developers, right? So like the users can just use them without necessarily having to know like what's going on and how the system works. Is that correct?
Yeah, is a protocol, right? Is a protocol that support layer 1, 2, 3 solution on top of it, right? So how much is embedded in the protocol can be just the survival of the network only. So with basic rules, like you are part of a list of nodes, if you are not showing yourself online, you're removed from there. There is a sort of reputation for this node to exist, and then whatever information transit it doesn't matter. And this is the basic functionality of the peer-to-peer network. When you can also start ruling what kind and what format of information goes through, or how it's transformed when it goes through, and that this goes to application like blockchain or IoT devices talking to each other to take the decision for a smart city, rather than. So I do believe that it's really individual to each peer-to-peer network to have a specific functionality implemented to do a specific thing. Blockchain as born with a peer-to-peer network, studied, implemented to support cryptocurrency remittance. And not much else. Then Ethereum came up with a smart contract. The smart contracts are logic to this money remittance. So you can implement very complex logic on how, in fact, they were calling it smart money, you know. So you can say, I pay to this account, automatically split to many other account, or if there is this condition there, then paying this way. So this give birth to decentralized finance. And this is all peer-to-peer protocols that adds complexity on how things are managed when data transit or is stored in nodes or transit through the network. There is close to no limit to these things. There are very interesting video conferencing software. They use a peer-to-peer network. They don't have a central server. Skype was born as a peer-to-peer network communication system before Microsoft purchased it and semi-centralized it. But when you were running Skype on your computer, even if you are not talking to anybody, you were acting as a node of the peer-to-peer network. So there were communication going through your computer, there were connection going through your computer. In fact, it was burning bandwidth. Many people were turning it on when they need to make a call, and off when they were not using it, because else it was acting. So if you had the reputation to be always online with a fixed IP address, automatically you were elected to super node, which was using you even more for traffic and important data storage for the network. And that is a nice thing, because Skype in fact was encrypted, secured. There was no way for accessing the communication. Law enforcement had no ways to be a man in the middle and listen to calls. So in fact, they needed to hack the starting and ending point. So hacking your computer and listening to what you say, I can listen to your Skype communication because I am before the communication, right? I listen to your microphone and speaker. But if I am in the middle, it was all encrypted and impossible. Then Microsoft took over it and all things changed. It's no more secure even in the middle, right? Many other chat systems like this are implemented on a peer-to-peer network, and it's beautiful because it's impossible to take them down, right? So there is always so more speed that there is in the network now with 5G, with a cell phone or fiber optic or other communication, Starlink, the satellite Elon Musk is putting around the world. Higher speed, more powerful processor, cheaper data storage like a drive. It's easy to get many nodes for anything you want to do. And one thing we want to do with the decentralized blockchain with DecBC is to give an appliance so people can run a node physically from home. And there's going to be one node of the peer-to-peer network to do several functionality for our system.
Okay. And what about Torrent actually? Because I think it's quite popular.
Torrent has been the first popular implementation of a peer-to-peer network, born for distributing files, but brought to fame when people start distributing pirate content online, and the existing systems like Napsters or the other were taken down from the law enforcement correctly because they had one central point of failure. They had one server that was centralized, was controlling the distribution. Torrent doesn't have it. So Torrent is impossible to be taken down. So at the point, the strategy for this major change in getting a few young kids arrested with hundreds of years of prison time for piracy to scare the public from using this tool because they had no means to taking it down. So if I were them, I would have used the network to sell my content around the world rather than trying to stop a monster that cannot be stopped and ending up not to be a nice guy for anybody, right? But so much is what happened. Different from the bank, when they saw the cryptocurrencies, they start thinking to do the government issue cryptocurrency. They start adopting blockchain for several internal use in order to control, determine the standard, and possibly implement legislation on the use of these things. Different approach, but
because I think like a lot of people associate Torrent with video downloading, where they can but people are
Torrent is used for a lot of legitimate cases. For example, if you need the latest Ubuntu Unix software, you download it via Torrent. There are a lot of it's strange when the association, but it's also true when something is used a lot for something that is wrong. The minor legitimate use that is there lose the right to say this is a legitimate network, right? I think when I was working in law enforcement, if there is a bar where a lot of criminal meets to organize robberies, to organize things, even if the owner of the bar has nothing to do with the criminal organization, the police, the government, the judge close down the bar to destabilize the center for the criminal organization at the expense of the owner of the bar that was a starving client. So I think that the approach of trying to shut down a network because people make use of this network for illegal things, if it should extend to everything. People use trade finance through banks to finance terrorist groups, for example. They should shut down trade finance, but they don't, because it's how the economy in the world goes around, right? But if the majority use of trade finance was just to recycle money and do illegal activity, probably they would think that it's not the case to keep it up, because it's a minority case. In all, cash is used to do a lot of illegal things. People pay hitmen with cash, right? People buy drugs with cash. but you don't ban cash, even though they're doing it slowly. But peer-to-peer network that are used for things that are not considered legally lawful by government are obviously trying to get regulated or banned or blocked. But it is hard to do so. ISP can do what is called packet sniffing, means they check every connection when they sell the connectivity to your home. They check the data that is transmitted. If belong to a particular thing, they can just stop it from reaching destination. That's why in many countries you go and you can use Telegram, but you cannot make a phone call with Telegram. You cannot make a call or video call because they recognize the packet for the request of video call. The UAE, for example, is classic like this. You can use a lot of application, but when you try to make voice calls that are encrypted, simply can't.
Oh yeah.
There are other way around to that, but they made like $1 million fine plus 1 year of prison if you use a VPN, for example, or tools like that, because they like to control the traffic, which people don't think it belongs only to those countries. Every country does this. The simple things is not evident if they block or make it hard to divert things, and sometimes people connect to the internet, there are services go super fast, the services go super slow, and you wonder why, if the connection is one, simply because probably some services are filtered, some services are directly open connection, either in source or the destination country. So data is tampered with in connectivity. That's why the real decentralization comes to the moment that also the internet connection is decentralized. So I don't anymore use my connection with the ISP, but I am a node of the internet. So I run like a server in my house with antennas where people can connect and access this internet, and so you decentralize also the access to the network and the network. In this way, you have removed completely. But there are laws that forbid to do this, for example, in my country, because it's a battle. For example, 5G for the telephone system, that many people think that it kills the birds and other thing, which is a little bit, people believe this because they are illiterate in the technological aspect. There is no such thing like radio frequency that is to the level become a microwave oven. That's not the case for 5G. The problem with 5G is that the network system of 5G is decentralized, which means that if I am making a phone call to somebody in the other room, my call doesn't go anymore through the phone company data center and come back to the other person. It's directly connected from me to the cell to the other person, which makes it impossible for government to spy on phone calls. That's why there is a huge movement against this 5G, and there are a lot of companies that produce the software or even the hardware to deploy 5G that are considered untrustable. I do believe that the innovation in the technology for communication that 5G brings in is a big inconvenience when it comes to fight organized crime, to fight terrorist groups, or unfortunately also to control political situations, because it's decentralized. So it's one further step toward the decentralization, even in the core system that we use, like telephony, which is one of the basic communication tools, right? Which imply also data connectivity and all.
Okay. And then, like, regarding supply chain, like, how does the peer-to-peer network improve supply chain?
In the supply chain structure, organization, there are many parts involved that are involved in the full process, mostly from different countries, mostly from different regulation and so on. To work together is hard. In fact, usually the minimum common denominator that they have is paper and pen. Like if I do a supply chain where I source some material from one country, other material from a completely different country where language is different, software used to manage things are different. What do I have? There are very few standards. There is emails, paper and pen that are shipped via courier, documents sent via courier, fax machines that are standard worldwide, but even in the fax machine, a form will be in a different language, etc., right? So the quality of data is a high risk. There is a lot of forgery of documentation. There is a lot of documents that need to be validated by an ending part. For example, a certificate of origin of some material. Let's say supply chain for medicine, which is an important thing for the pharmaceutical industry. I need to make sure that the ingredient used to make these pills come from a particular factory. But if the document is made of paper, and it changed 5 lines before coming to me, who can tell me that the documents I'm holding in the hand is originally from the company and not being counterfeited through the supply chain, right? So a peer-to-peer network in a supply chain allow the different parties to communicate, and a basic set of rules can be put in order for the documentation to go through. One beautiful thing, for example, the blockchain allow is the unicity, the singularity of digital assets. So the certificate of origin issued by the factory that makes the things in a context of a blockchain or a peer-to-peer network is unique, it cannot be counterfeited. People can add a notation to it, but when it arrives to me, I have no doubt that it is originally signed and issued by that particular factory. And this guarantees quality. You also can automate process for say, you cannot sell to me this content unless it's accompanied by the digital certificates by the origin that the system can verify to be true. So it doesn't matter in what language it's written, but just to have the digital signature from a recognized source that cannot be counterfeited as a documentation to accompany some parts that comes together to build something that can be resold. This gives to the final user of the item that the supply chain put together the guarantee of the origin of everything, single part. This can go for the organic food, this can go for quality of vehicles, this can go for all the parallel imports, all things that are going on. So it's very powerful without conditioning the need of a use of a particular software, because there are attempts to do these solutions where supply chain, in order to guarantee, for example, there is an electronic bill of lading, but this electronic bill of lading cannot run in a peer-to-peer network freely, right? It has to be issued with a particular software solution, run through the data center of this company that does this software solution, which means that producer, shipping company, freight forwarder, and the clients on the other side, they all need to have a license of this software, be subscribed to this company, use their data center. As soon as you want to ship the container, rather than go to a ship, you need to go to another because the ship is broken. If the other company is not subscribed with this software, you cannot hand over the bill of lading to them because they have no means to collect it. If it was an open peer-to-peer network, they would just take their cell phone and download the application that is there for everybody and make a KYC process to be in, but without needing to go through all the rule book, all tens of thousands of dollars subscription, and they will be able to handle a digital document that remains unique and has an audit trail that is registered clearly in the end of everybody. So that's powerful, right? And here is a case where a central solution totally loses next to a decentralized solution is implemented on a peer-to-peer network.
And the peer-to-peer network also automates the whole process, right?
You can implement rules on the peer-to-peer network where you can say this document can be forwarded to this other party only if these conditions are met, right? When you start doing this, you need to make sure that all the parties involved are in agreement with these rules, because if people work in a different way, they will have other rules. So you can remove validation of this thing from humans on different ends or parts of the process to automate it, but then you need to guarantee that everybody is in agreement with the rules that are implemented centralized, right? Can be different rules, so you can create system where people vote or people agree to do a certain procedure following this mechanics rather than that. If there is an ecosystem of different proceeds that can be automated where the rules are guaranteed by the peer-to-peer network, then people can choose to follow one rather than another, and then they can proceed with the guarantee that rules being respected,
Okay.
without anybody being the judge. The judge is the network, right? Simply things don't go through if they don't respect the rule.
Okay, that's why it takes longer processes to manage the peer-to-peer network.
Yeah, wherever there is no central authority to make a decision for everybody, it's harder to get everybody in agreement, to do something. But I think that if we move in this direction, they were talking about using voting for political election in a peer-to-peer network, the centralized system, to guarantee everybody who voted really voted, doesn't vote twice, the vote casted is that and nobody tampered with the results, and so on and so forth. But there is the need to have the will to do so. So when you remove the power of somebody to manipulate data, and he's the one deciding if you should use the system or not, obviously he's never voting to be removed the power to manipulate data, right? If his business is around manipulating data. So it's a battle that need to start from the bottom up, and need to be adopted by the people. People need to understand how it works, why it's convenient, and help promote this. Make sure that it's growing with the neutral approach of everybody. It's a very complex process, but nonetheless we're moving in that direction. So
through social engineering.
There are a lot of we saw is with Facebook how people be manipulated in opinions easily, so that will not change because you cannot change the source of an information, right? So it's like automatically a peer-to-peer network make people ethical. You change the system, people is gonna act in the same way anyway. At least you can make accountable the people that do that. You can have a better audit of what happened, and that is transparent in the front of everybody, right? That's the road to decentralization that is gonna take the time that it's gonna take, but that's the direction that needs to be adopted, right?
So my final question, and it's also still related to the supply chain and peer-to-peer network applications. It's about decentralized finance. So what are the concrete examples of decentralized finance and how the finance sector has developed the decentralized system so far?
So that's an interesting evolution. So when Bitcoin came up because of the 2008 bubble that created a lot of people broke, but bank has been saved by government. There was a lot of people unhappy about what happened. So there was this need to have money that is not issued by a government, but is issued by people and controlled by people, right? Bitcoin needed the blockchain and needed the peer-to-peer network, and so adapted the existing solution to implement this cryptocurrency. But Bitcoin wasn't about the peer-to-peer, it wasn't about the blockchain, it was about money made by people for the people, right? And the evolution been around the cryptocurrency, the evolution of the bottom layer technology being around cryptocurrency. And what Ethereum added to the paradigm was this intelligent money, right? The capacity to make money do things in an intelligent way, which evolved in a very complex manner, being able to mimic service offered by banks in a decentralized manner, though. So the guarantees and all are not decided by a human that says, I trust this person because he's the cousin of my wife, rather than I don't like him, so I don't give him trust. Or people fake documents to bring at the bank in order to get a grant that they shouldn't get, and so on and so forth. But being decentralized, the rules are very clear, so either mathematically makes sense or not. And then people can leave collaterals to get a loan, can leave collaterals to get interest in the collaterals because other people get loans. And it's very interesting that you evolved in a way that is not only something that is mythological or for multi-million, but people is actually taking a loan through decentralized finance, means that no bank is involved, it's all just software in a peer-to-peer network that nobody has control over, but somebody create. And they take the loan to buy the car, to buy a house, leaving the counter value as guarantees that they can pay back the funds, but without losing the counter value. It's interesting, for example, in Germany, a company got a license to create digital assets representing real estate ownership in the blockchain. Means so you have a house, you can create a token that represents your house value, and then use this token in decentralized finance to get a loan to buy your car. So you can leave your house as a guarantee once you pay back the purchase of the car. Let's say you buy the car and then monthly you pay back a certain amount with the due interest. At the end of the payment, you can get back the token that represents your house, and you have current house, and you paid in a monthly installment without going to the bank, without signing any contract to the bank, which is powerful. And if you fail to pay back your car, then the house get ownership by whoever the money. So that's pretty powerful. And the only thing stopping this evolution are two aspects. One is the user interface. They need to be simple and such that any person that is not tech savvy can use, and with the security and trust of what is going to happen, which is not the case of today. We need to be tech savvy and understand what's going on. There's a lot of scams because people can create fake user interface. So there is a process that is important to validate that what people are using, what they put in the money is authentic rather than not a fake. And the bridge between physical assets and digital assets, which is a beautiful evolution that happened with the NFTs, where artists can put their art in an NFT. But also there it happened that there are a lot of artists that saw their painting being sold as NFT without them even knowing, and the painting is with them because there is obviously new opportunity, new scams come along, mostly when it's unregulated because it's decentralized, so it's impossible to regulate, right? So people can get arrested to have done a scam, but there is no way to stop somebody from creating an NFT with a Colosseum and somebody else buying the Colosseum, right? So, but these things is not the technology that empower people to do. People were doing this scam even before. There are people selling the stars in the sky with a certificate to people, who's can go claim the ownership of a star. Doesn't make sense, right? But this thing exists. So it's much more difficult to protect people in front of a decentralized system because there is no stop from anybody to use it. Anybody can use it. At the bank, they can stop me from getting a loan. In a decentralized system, nobody stops me from getting a loan. I can get it, right? If I have the counter value to deposit. And this is one of the aspects. Many people lose all their Bitcoin because somebody scammed them and so on and so forth.
Yeah, but on the other hand, in terms of communication and supply chain, the peer-to-peer network and decentralization can actually make it more efficient for people to complete their affairs and get their needs met and to distribute their products, and also guarantee the security of their data, so it won't be sold to, for instance, the government or
you're in control of what you do and what is out there, right? There are plus and minus in everything, right? There is not an absolute plus and absolute minus. I do believe that the big things with the decentralization and peer-to-peer network that allow to decentralization is the removal of a man in the middle. So if I'm sending some money to somebody else via crypto, it goes from me to the other person. Via bank, I ask the bank tells the other bank, the bank will pass it to the other person. So people is dependent on the things. A man in the middle doesn't work 24/7. So if it's a Friday night, I need to send some money on the other side of the world until I wait Monday, then they start a procedure that is gonna last another 4 or 5 days. While with crypto, 24/7, I can send it. It's also true that if the title of ownership of my house is also in a title that is decentralized, and it's Friday night and I'm drunk, I'm at the bar and I see a beautiful girl and I tell her, this is my house for you. There is nobody stopping me from doing that, unless the system is programmed to avoid things such this, right? So it says you need to wait 5 days confirmation, or there must be a government agent to approve the transaction after they talk to you on the phone. So there is a lot of work to do to make things safe and functional. In order, for example, with NFT, there should be a registry of registered authors. Only when they register there, you see an NFT. If it's generated with their signature, is authentic. If not, you know what I mean? So an agency that take the job on doing the KYC, do the verification that is really the artist, is not somebody pretending to be them, etc., etc. In that case, NFT become valuable because they're authentically from that person. So
and like the developers are now still enhancing the security of the peer-to-peer network to just minimize the possibilities of like somebody's changing the rule or like.
Peer-to-peer network is like a phone system where people can call each other. It's hard to stop people from saying something or pretending to say something. You enable a communication system. Then you can start creating layers of control of the content of the phone call if you want. You know, automatically hang up if somebody says a certain word, and means that there is rules that control. But whatever can be controlled cannot be hidden or secret, right? Because to go through a rule of approval, the data has to be exposed. So there is this giveaway. If everything is encrypted and secret, there is no way to control. If I want to put the rules, then data has to be exposed in order to apply the rule to the data, right? So let's say a certificate of origin. I wanted to say that there is a certain quality percentage above 97 in order to be good to do the medicine, and I want the system to stop a certificate that doesn't have the quality inside, then the quality has to be exposed. Everybody can see it, so that the rule can apply to the certificate. If I want to keep the certificate secret, there is no way that the peer-to-peer network can stop something they cannot read. Right, so it is applied with everything else. So
but as long as you trust the people in the network, regarding the security of your data, it's fine, right?
Right. So what you get on top is the authenticity and the unicity of a document, which can be encrypted. Then it's part of the person to say, hey, I decrypted, I read this, the quality is not good, sorry, I cannot go ahead with this. People can. But you can automate the processing as well. Unless there are metadata just with the key information, but everybody can read them. Because the peer-to-peer network is open, right? Any party that is in the network, even if it is a virtual private network, can see the data in the network. So there is no privacy on data that need to be used for rules. That's it.
So, but then like the difference from the centralized system is that like the data will only be exposed to like the nodes inside the network, right? Not to like a server.
But in a centralized system, the server can be private to one person, and this person see all the data. You work as an IT to the bank, you can see everybody's data. There is no way, because if they can access data, they cannot even work as a bank, right? So the secrecy there is given by legal contract between the employees and the bank, between you and the bank, but people can break this contract, right? So it's classic that IT department in banks sells out the information to private investigator and things. Is a common procedure, unfortunately. Insurance and so on, right? In a peer-to-peer network, you can encrypt the data and it's not exposed, but because there is no central part that is kept secret by blocking people from saying things, but the peer-to-peer network is open, anybody can add one node to a peer-to-peer network, right? Even if it's a closed network, but you need to be part of it, they need to let you access the network. So once I can put a server, I can see the data in the server because I just simply open it. It's like if I am the operator, with the difference that I have not much of a rulebook or legal framework which stop me from sharing the information, right? Because how you know who did share the information? So the tendency is that the data that are transiting through a peer-to-peer network, if they're encrypted, then nobody knows who they're for. If there need to be rule applied to them, there is a science of mathematics called homomorphic encryption, which allows to do analysis on encrypted data. But we're far from having a practical use of this thing. So usually, without some trickery, data need to be exposed to the network to make a reasoning out of it. So yeah, I think that closes a little bit overview on
the peer-to-peer network.
You can record later.
Yeah. So I think we can conclude our discussion here, so as not to make it too broad, and also now hopefully you can begin to understand how the peer-to-peer network works, and then how does it differ from the centralized system, along with the applications, especially in terms of the supply chain management and the decentralized finance. And if you have any questions, leave your comments on the comment section on our YouTube channel. If you're watching this on YouTube, or if you're listening to the podcast, you can go to our website and leave your comments there as well, and questions if you have any, if anything is still unclear from this discussion. And so thank you for staying with us right through the discussion, and next week we will discuss about the NFTs and how the NFTs are being applied. So be sure to follow our podcast and also follow our YouTube channel Blockchain Zoo to learn things, everything about decentralization. So I'm your host Sebastian Partogi. Thank you, and see you again next week.
Thank you. Bye.